is 1.9. Inverse functions. Y'all have done inverse functions before. We've done them in Algebra 2. So for an ordered set, so we know that an ordered pair can represent a function. For instance, f of x equals x plus 4 from the set. So 1, 2, 3, 4, 5, 6, 7, 8. Because 1 would go to 5, 2 would go to 6, 3 would go to 7, 4 would go to 8. Yes? Because 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, and 4 plus 4 is 8. So we get these kind of ordered pairs. Now we can say that the inverse, denoting as f of negative 1, is going to be the flip. Essentially, we're switching the x and y. Because a function f of x is going to take a value from the domain to a range. The inverse is going to take that value from the range back to the domain. It's going back, okay? Known as the inverse, or undoing each other. So in other words, f of f inverse of x, so we're still using that x minus 4. If we do use our composition of functions, which we did in 1.8, will give us x. And if we do it the other way, it will still give us x. Is a composition of two functions that are inverses will give us x. If it doesn't, they're not inverses. Okay? And we'll go back in through exactly how we find the inverse, because they just gave us that one. Find the inverse of this, then verify that both f of f inverse of x and f inverse of f of x are equal to each other. There are some steps. Step number 1. Switch f of x with y. 2. Swap x and y. 3. Nope, didn't mean to do that. 3. Solve for y. And lastly, replace y with f inverse of x. Okay. So we had those steps down. If for some reason you need to rewatch this, all you got to do is back it up and you're good to go. So f of x equals 4. So the first thing we do is we replace f of x with x. Then we switch x and y. Now the numbers and signs that they had that are with x or with y do not change. We're literally just switching the values of x and y. Because our function took a value from x and put it to the y value, yes? The inverse is taking a value from y and moving it to the x. What did we do? We switched the x and y, yes? That's what essentially we're doing here. Step number 3, solve for y. So we get y is equal to x over 4, and our last step was to replace y with f inverse. That's it. That's all we have to do here.
I feel like we did a little bit of this last year.
Yep, we did this in Algebra 2. We talked about this some, dealt with this some. And we also talked about the vertical line test. No, horizontal line test, because vertical line test tests to see if it's a function. Horizontal line test tests to see if it has an inverse. So if you remember the vertical line test, if you can draw a straight line anywhere on the function and it crosses 2 or more times, it's not a function. If you can draw a horizontal line, a line going straight across, I'm going to stop doing the hand motions, because if we can draw a line like this across the graph and it crosses 2 or more times, it does not have an inverse. It does not have an inverse. Now, it can have an inverse, but we have to add limitations. So I'll use a different color. This here is a quadratic, yes? So if I drew a horizontal line, let's use this, it crosses twice, yes? So it's probably going to talk about, I'm getting ahead of the slides, I know I am. This does not pass the horizontal line test, does it? So it does not have an inverse. However, if we said, we'll just call this the basic quadratic, semicolon, x is greater than or equal to 0. What does that mean? It's only talking about the points from here this way, yes? So this half doesn't exist anymore. Does it pass it now? Yes. So there are some functions we can have an inverse with as long as we restrict it to certain values. Okay? Now the reason for this is because this here becomes our inverse. As long as I keep with the x is greater than or equal to 0. The other half, let's do it in yellow, why not? This side over here would be down here. Is this a function anymore? No, does this red and yellow one pass the vertical line test? If I draw a straight line down here, well, no, it crosses twice, doesn't it? That's why it doesn't have an inverse. Because if it fails the horizontal line test as a function, f of x does, its inverse won't be a function. Can we still graph the inverse of it? Yeah, we can have this. That's fine. But it's not technically a function. Does that make sense? Yes? Kind of, sort of. I mean, it doesn't work because we have two numbers that would match up to the same thing. Two x values for the same. One x value for two y values. It just doesn't work as an inverse. But we do have one. It's just not technically a function across all real numbers. That kind of lock it in place a little bit. I mean, it's not huge. It's not huge details. It's just something to remember. Okay? I just realized we didn't finish this problem because I got off on my tangent. It's just verify that f inverse of x and f of f inverse of x and f inverse of f of x give us the same thing. So I'm coming back to this here. So f inverse was x over 4. And this will be good, Tori, for the composition of functions, which we did in 1.8, just because you missed that day. F inverse of x is what? X over 4, yes? So we're replacing it right there. Essentially what we did is we plugged in x into this here. Well, that's just x over 4. Doesn't really change anything. Now f of x is what? 4x, yes? Do I have x anymore? Do I have x over 4, yes? So what I'm going to do is I'm going to replace this x with x over 4. So I have 4 times x over 4, which is x, yes? 4 and 4 cancel and we get 4. Okay. So that worked out exactly like I wanted. So f inverse of f inverse of x is x. Okay. So f of f inverse of x gave us x. Now we're going to look at f inverse of f of x. F inverse, well, f of x is just 4x, yes? Because I'm replacing x, putting x into f of x. Doesn't really do a whole lot, so it seems weird. But now I'm going to plug in 4x into our f inverse, which was x over 4. I just realized I erased it. So we have 4x over a. 4, not x, 4. 4. Well, the 4 and 4 simplify to so f inverse of f of x gives me x, yes? So these are inverses. These are inverses of each other. Because what it's saying is, when I take a value from the, essentially, so what we say, f of x takes a value from x to y. Its inverse should take that y back to the x. They should give us the same thing no matter which order we do them. Okay? So really it's saying, here, I'm taking my x value, I'm taking it to the range. Then I take the inverse, I'm taking it from that range back to where I started. F inverse of f of x and f of f inverse of x should be the same because it's saying I'm starting here, starting at one point, so I'm starting at point A and going to point B and then coming back. It should be the same path no matter where I start, yes? Because if I go from here to Tulsa and then go from Tulsa to here, it should be the same as going from Tulsa to here and then going from here back to Tulsa, yes? No matter where I start, I should be, my start and end points should be the same if they are inverses, if I'm taking the same path. Does that make more sense? That's what this is checking to see. Are they inverses? Are we going the same route? Because it's not always going to be the case that they go the same rate, same way. Because if we're going from Concord to Siloam, well, I can go from Concord through Kansas to Siloam. Or I can just take a right out of here and go that way, yes? So there are ways that they don't do the same thing. They're not inverses. And that's how we check, is by doing this here, f of f inverse of x and f inverse of f of x, so doing both, okay? So let f and g be two functions such that f of g of x is equal to x for every x in the domain of g, and g of f of x equals x for every x in the domain. Therefore, they are inverses. Because if I take f of g of x and g of f of x, and they both come out to be x, then they are inverses. Under these conditions, g is an inverse function of f. Do not be confused by the use of -1 to denote the inverse function f inverse of f, f inverse. In this text, whenever f -1 is written, it's always referred to as the inverse of the function f, and not to the reciprocal of f of x. And when it's talking about reciprocal, it's almost like if we have x to the -1, well, that's the same as 1 over x, our negative powers, our reciprocals. That's not what it's talking about. We don't normally talk about reciprocal functions. Not normally. If it's a reciprocal, I'm going to just name it a new name. Instead of using f, the reciprocal of f of x, I'm just going to call it g of x is the reciprocal of f of x. I'm going to give it a new name. If the function of g is an inverse of the function of f, then, as we just said, it can be stated true. Okay, this is what I was kind of showing you earlier, this graph here. F of x is this one. F inverse is almost a mirror image across the origin. Do y'all see that there? So this here is a function because either one of them passes the vertical line test. Yes? So it works. And I can throw that screen around. Sketch the graph, this, and its reciprocal, this. Again, I'm not too worried about graphing, because I think at this point y'all will have a good understanding of how to graph. Yes? So we end up getting these two lines. Doesn't matter, 1 to 1. 1x to 1y. I know I'm skipping over some of this stuff, and some will look down on it as something I shouldn't do, but so here's the horizontal line test I talked about earlier. So since it doesn't pass the horizontal line test, it crosses at 2 points, it doesn't necessarily have an inverse, quotation marks. But it can if we restrict the domain of the main function when we take the inverse of it. Okay? Questions on this here? We good with this here? Yes? Find an inverse algebraically. Isn't that what we did earlier? I mean, what we did with f of x equals 4x, our main 4 steps. Here they do it in 5, verify. I can add that, but always get ahead of these notes. Okay. Let's do this one here. Steps don't change. Numbers might, steps don't. So first step, place f of x with. I'm going to put a pen in my pocket, so it will write. Then what? Switch the y and the x. And then solve for y. Yes. Thank you. That'll change things. Now, the first thing I would do is multiply both sides by 2. I don't like fractions. If I can get rid of fractions, I'm going to get rid of them. Then what? We would minus 5 from both sides, yes? So 2x, then what? Divide by negative 3. And we get this here. So it tells us that f inverse of x is equal to 2x minus 5 over negative 3. Yes? Yeah, that's it. Now, we could rewrite this negative. I can move it out front and write it like this here. Or I can move it up top to the numerator, and it's going to change the signs. Because it would have negative 2x plus 5 over 3. All three of these are the same thing. It's just how you want to leave the negative. Most textbooks are going to stick with one of these two here. They don't like leaving a negative in the denominator. Don't know the reason why, but they just don't. They like moving it out front or moving it up top. One of the two. I stick with this method here because it's a little bit nicer, a little bit neater to figure out where the negative's at. And then we can check it by doing our f inverse, or f of f inverse of x, and f inverse of f of x. Yes. Doing these here and plugging them back in. With a lot of them here, it gets very complicated very fast, especially when we deal with fractions. It's just very complicated to look at and work. Sometimes, even if I'm not paying 100% full attention, when I'm checking these, even though I literally just worked this out, yes, we know these are inverses because I found them to be inverses, I still get the checking a little squirrely because it's easy to do. So sometimes when it's asking me, are these two functions inverses? If they're not too bad, I will do the check. I will do the check. I'll write it here. F of f inverse of x and f inverse of f of x. This checking to see if they are the same. But if it's a little complicated, I feel like I'm going to lose numbers or get stuff not straight, I literally just go through the process of finding the inverse. Even if it gave me the two functions already, if it gave them to me, and I have a feeling that they're going to be two things like this here that are going to be complicated to keep everything straight, I'm going to pick one of them. So I picked that one. Find its inverse. Does it match the other one? Hey, it does. They're inverses. If it doesn't, no, they're not. And that's it. Questions on this here? Solution goes through. Oh, yeah. Done, done. We get that there. Now, this here's a different one. So we have x on top and bottom. So if we want to do it, we switch. Let's actually do this one here. I know it's all written out there, but okay. I want to show you this because this one's harder to work because there's more than one x, yes? So the steps don't change because we rewrite it as y equals 5 minus x over 3x plus 2. Then we would do what? We switch x and y. Now, whenever we get to this point and there's more than one y, you need to group them together. You got to group them together. Because we're going to get, what we're going to do next is we're going to get the y's out of everything out of the denominator, out of the bottom of this fraction. So what that means is on both sides, I'm going to multiply it by 3y plus 2. Which for the right side of this is no big deal. They're gone. The left side now I have x times 3y plus 2 is equal to 5 minus y. We're going to have to multiply. So 3 times x times 3 is 3xy plus 2x is equal to 5 minus y. Yes? Now this is what I said a few minutes ago where I said we're going to group the y's. That's what we're going to do here. That's what we were aiming at. We're grouping the y's. I want all the y's on one side, every term with y on one side, and I want every other term on the other side. I'm just going to add y. It doesn't matter which direction we go. I'm going to add y over here. Add y to both sides because these two will cancel. Y and 3xy are not like terms. This one has y, that has xy. They're not the same. Are all the y's on the same side? Are they by themselves? No. Now, one of the things we do is we group them, and then we need to make sure they're by themselves. So I'm going to subtract 2x from both sides. Because this whole process isn't quite intuitive. Because what I want to do is I want to get all the y's on the same side and by themselves. Yes? Now, these two terms here have a greatest common factor of what? Y, yes? And this is the reason why we did all these steps here, is because since it has a greatest common factor of y, I can factor it out. Y'all see that there? That's why we got them on the same side, by themselves, so I can factor y out. So how can I get it by itself? Yes. Well, F inverse of x. Yeah, but that's it. So this one here is probably the most complicated one you'll see. We won't do too many with quadratics. If we do, you'll just be using square roots. Let's see here. So we have this, it goes all the way down, and that's it. Now, why not? Let's do one. X is greater than or equal to 0. So this does have a function because we restricted it, so that the values of x are only greater than or equal to 0. Now the steps won't change. we'll get y is equal to 6x squared minus, then what? We switch. We would add 4 to both sides. Plus 4 over 6, and then we square root. So y is equal to the square root of x plus 4 over 6. Now we normally would do plus or minus, yes? So domain and range. Now for our original function f of x, we said the domain was what? Greater than or equal to 0, yes? And it maps over, well, all y values that are greater than or equal to 0, yes? Because for x squared, it starts at 0 and goes up. So it's only those values. So that means when I come back across for the f inverse of x, my x values are now what? Only greater than or equal to 0, yes? So could this thing ever be negative? So it's only going from positive numbers to positive, positive to positive? Nope. So for this here, we don't need it. Now if it had restricted it to x being less than or equal to 0, it would go from these here would be negative going to positive, but then we'd have positive going to what? So it would still be to be negative. Then it would be negative. Y'all see the main difference there? I mean, it's subtle. It's subtle. If I hadn't have pulled that out, we'd have missed it. Okay? Nothing too bad.